How's everyone doing? Last talk of the day, right? So we'll try to make this good, make this exciting, and then we can go to Epcot afterwards. That's what I heard. So that sounds sweet. All right, thanks for coming. So this is our talk, WAFs for the win, a modern DevOps approach to security testing your WAF. This is showcasing an open source tool called FTW, the framework for testing WAFs. Now, to the astute observer of the English language, we had a prime opportunity to call this WTF, WAF testing framework, but we thought of it. We tried, and my boss at the time said no. So this is what we're going to do. Yeah.
We already got the PIP name reserved. So.
Yeah, that's very true. So to get things started, we're going to do a quick intro.
I'm Christian Perron. I do security research at Fastly. Also, I'm a big advocate for open source related stuff. Done a little bit of work over the years in that area. I primarily focus on threat and vulnerability research.
Hey, how's it going, everyone? My name's Chaim Sanders. I work as the security lead at a company called ZeroFox that focuses on social media security. I also lecture at the Rochester Institute of Technology. And when it comes to OWASP, I'm the project leader for the OWASP core rule set. And I'm also the chapter co-lead for OWASP Baltimore.
Thank you, Chaim. And last but not least, my name is Zach Allen. I work at ZeroFox as a manager of threat operations. And for my day-to-day, I do a lot of threat intelligence work, but I've also done a lot of work in distributed systems and web security. So this talk, it's about WAFs, web application firewalls. Being an OWASP member here, we all know the importance of web. So according to CADA, HTTP and HTTPS take up about 85% of internet traffic. As a result, web architecture is very complicated. There's a lot of different stacks, a lot of different configurations, a lot of different applications and platforms, which Christian, his company deals with, and he'll get into more. But what this really means is that we need a good defense in-depth kind of strategy for securing these types of web applications, and WAFs are a proven technology to be part of that strategy. So as an engineer, though, it's kind of hard to evaluate any security product. It's even harder to evaluate a WAF product. So you can kind of go down this list, and you could go to the vendor hall a couple rooms away, and you can say, okay, well, is it fast enough? Is it effective enough? What kind of support do you have or documentation? But those are very like qualitative yes/no answers. It doesn't really tell me as like a scientist or an engineer, is it going to secure my organization? What use cases is it going to solve? It's like a really hard thing to capture when you're evaluating these things. So one attempt to kind of capture the effectiveness of these different technologies, or our favorite thing, especially for our managers, are the Forrester and Gartner analyst reviews. So on the left is the Forrester Wave, and this was a Forrester Wave for WAFs in 2006. And on the right is the latest Gartner Magic Quadrant for WAFs. So when I go and see this, and when I see these reports, you kind of get like an overview of the different reviewers and different analysts going through these different technologies. But it's kind of hard, me being a data-driven person, to say like, okay, the Imperva bullet on the Magic Quadrant on the right is kind of more towards the top right, and I think they're a leader. But I also see some visionary stuff down there. So do I want the visionary WAF, or do I want the leader WAF, or do I want the challenger WAF? These are very kind of hard definitions for us to wrap our hand around. Now, in terms of Gartner's inclusion requirements, these are it. So I won't read them all off, but they have 8. And we bolded 2 of them. The first one being to get onto the Magic Quadrant, the WAF technology is known to be approved by a QSA as a solution for PCI DSS. That's kind of like not that good of a requirement, because when you think about it, let's just say the PCI DSS says, okay, you got to protect against SQL injection, yes or no. I can make a WAF that can protect against one SQL injection attack, and I will probably be PCI compliant in that aspect. Also, the last bullet, Gartner analysts will not put on a WAF that is essentially mod security repackaged. And that's also an interesting observation, because mod security, being around for as long as it's been around, has a lot of knowledge and community knowledge associated with it. And there probably are some pretty decent WAFs that use certain parts of mod security to go and roll out these types of technologies. So really, when it comes down to it, it's kind of hard to look at these reports and to really say like, okay, based on just this information alone, I think I'm going to go with these top 3 WAFs, for example, that I'm going to go out and try to purchase. It's very qualitative. So Another thing that you can use, which is an OWASP project, is the WAF or WAF, Web Application Firewall Evaluation Criteria. It helps stakeholders understand what a WAF is and what its role is to protecting websites and web applications. And it's a really useful tool to help engineers make an educated guess decision when selecting a WAF. So you can get like an Excel spreadsheet. It looks like a security questionnaire, but it's very hyper-focused on WAFs. And this is actually a really good thing to use, but it's still kind of qualitative. For example, within the WAF, it says, does it protect against SQL injection attacks? So how do you evaluate the effectiveness of protecting against a SQL injection attack? All of them, some of them, the most popular? Does it depend on the application? Does it matter on SQL versus Postgres? It doesn't get deep enough for us to really feel good going to sleep at night when you make that purchase decision. So really what it comes down to is the idea of qualitative versus quantitative metrics. So the qualitative metric, softness of me petting my dog. My dog is super soft today. It's very qualitative. There's nothing really to measure what it means to be soft, or what is the color of the sky today. These are like those yes/no questions that I was talking about before with Gartner, with Forrester, and with WAF. When we designed this tool, we really wanted to move parts of that evaluation kind of process into the quantitative column. So this quantitative data can be easily measured, and it can be a number. So for example, how long can Chaim go without being loud or not saying a swear word? Or how many Labatt Blues can Christian drink in 10 minutes? Those are things that I can write down and I can measure. And I can measure it for today, I can measure it for tomorrow. And those are really, really nice things to have when it comes to figuring out the quantitative metrics behind a WAF. So in terms of us getting these quantitative values, we asked ourselves a couple research questions on how we can use it. So we definitely want some type of quantitative values to make a purchase decision. And this is more for the engineer kind of implementing these things. We also want to baseline some functionality. It's much easier, especially during a bake-off, when let's just say you want to evaluate 3 WAFs, to have some type of baseline to go off of. Because then you can measure how well they performed against that baseline as part of your decision criteria in purchasing the product. Next, we wanted to be able to test new rules or vulnerabilities. The core rule set, which Chaim will talk about a little bit, and even all those companies in the Gartner Magic Quadrant, they're going to want to maintain a database of new rules and signatures for attacks that are like happening right now. So if we can create some way to quantitatively even measure that, we think that would be useful to have. And lastly, regression testing, whether you're putting out a new rule config and then you bust 5 other rules, or you're developing a WAF and you fix one line in a 300-character regex and then things just start failing, we need something to quantitatively measure if things are doing well or if things screwed up and we need to fix it. And lastly, really just to test the security effectiveness, that kind of can I sleep well at night knowing that I bought the right thing for my company? And we really designed this tool to integrate with modern development approaches, which we'll get into now. So FTW stands for the Framework for Testing WAFs, not just for the win. It is a Python project that heavily uses the PyTest framework. The PyTest framework is essentially a unit testing, integration testing, and regression testing software framework, and we wanted to integrate security testing on web attacks into Python so that when it's run, you can run it like any other piece of software that fails these unit or integration tests. The idea behind it is that we take a test case in PyTest, and really that's just a web application attack. It could be anything from cross-site scripting to SQL to whatever you want to write, as long as it's an attack that can go on the wire. And then that has a fixture defining the attack, and then you essentially go and test it against whatever system you want. Then that test suite goes and becomes something that is like a comprehensive baseline and a corpus of attacks for you to issue against these WAFs that you're evaluating. And the basic idea for any type of unit testing or integration testing is you write the test, being that you write the attack. You run the test, does it pass? Did the WAF respond correctly or did it not respond correctly? And then you go back and you keep rewriting the test to see if it's you screwing up the test or if it's the WAF not being able to protect against the attack that you're specifying. So this all really started off with the idea of a bake-off. I talked about the Magic Quadrant. I talked about the Forrester Wave. We essentially wanted this ability to deploy a WAF that you're evaluating, FTW on top of it, which is a corpus of those tests I was talking about, and just issue a battering ram of these types of attacks against the WAF. Now, if you catch them or not, that's going to be part of your evaluation criteria of whether or not you should purchase this. And then you can compare that against other WAFs. But a funny thing started to happen when we were building this. Pretty much the same kind of flow diagram, but the decisions now are about regression testing. This is particularly useful when you're developing a WAF, when you're making those regex changes in that huge string of regexes. We want to make sure that if you have 500, 5,000 pieces of attack that you know to protect against, you then issue a code change to your WAF that breaks 100 of them, this will be able to stop it because it sits outside of that, and then it's finding those vulnerabilities or it's finding those regressions as they come up. And lastly, 0 days. This is also very important. When my manager comes to me and is like, hey, I saw that Apache struts vulnerability. Will we be Equifax? And then I say no, and he needs to say, okay, prove it. I can then show an FTW test that emulates that struts vulnerability, and it's an actual exploit to go and issue against our WAF, and then I can go and show him the log, I can show him the status code, I can show that we're actually protected. So now that I went over FTW, I'm going to pass it off to Chaim, who will talk about how the core rule set project is using it.
Cool, excellent. Thank you, Zach. Thank you. So what we're going to first talk about a little bit is what were the goals of this? So Zach talked about, hey, we have this idea, we have these use cases, we have this construction, but what were the original goals? So the first goal that we thought of was we said, well, if we're going to be testing these things continuously, we're going to need to actually push these through with some solid baseline. And it's unfair to choose an exact vendor for this, and nothing's going to be particularly fair. But the one that we chose was the core rule set, and that's really how I got involved with this process. The core rule set makes a lot of sense here, not only because it's featured in a number of web application firewalls in different forms already, but also because, first off, it's sponsored by OWASP, which is an open organization. It's an open source project itself. It's fairly trusted throughout the industry, and it has years of iterative maintenance, which means that a lot of the base issues you would start with are already done. So you don't have to worry about like vendor-specific leanings because, well, it's just an OWASP project. The next thing we did is we wrote a corpus of rules that triggered all of the inbound CRS rules. So we wrote FTW rules that would trigger these actual alerts with real attacks. So that takes a lot of time, thousands and thousands of tests we're talking about here. After we have the baseline of attacks that we want to talk about, we have to go a little bit further. We don't just want these attacks to be useful, we need them to be easily written. And this is something that we really strove for really heavily. So we don't want necessarily security engineers being the only one to make these tests. And to aid that, we actually allowed ourselves to specify it via a nice YAML format that we'll be talking about in a couple of seconds. The last big feature, and the feature that you might be thinking about is, well, how do I integrate this across different web application firewalls? My environment might be different from yours. Even using a standard firewall like Mod Security, you have people who push that to Elasticsearch, you have people who use the file version. When using things like Imperva or Amazon WAF, you might have something in CloudWatch, you might have something in a GUI. You really need to manage these logs in a modular way. And this is something that we provide by default, a very easy to use log integration tool. So with this in mind, we actually kind of want to know how we do this, right? So the YAML tests are a little bit interesting. We followed the model of SCAPI. So probably some of you are familiar with SCAPI. Around of anybody familiar? Yeah, there's a couple. It's a networking programming library for Python. And one of the beautiful parts about it is if you create a packet, it will just fill in the base packet for you. And you just make changes to that. So you say, I want a DNS packet. It'll give you a DNS packet, and you just slightly change some stuff. We decided to follow that exact model here. And so the base request that we make is a standard minimal HTTP 1.1 request that you see right there. That means that when you send almost nothing, you're going to get that. And we'll see an example of that in a couple seconds. In addition, we want people to be able to make these tests readable. I know a lot of you have lived through the 2000s and XML. We're going with YAML here. It's a little bit more readable and easy to write. So here's an example of a test, and this test literally does nothing. You don't actually need almost everything I have here. It's just going to make a base HTTP 1.1 request, as I kind of just showed. The metadata that's listed there is optional, but I'm a big fan of documentation, as you might assume. And there are quite a lot of interesting things, but the interesting thing to note is that the input area is blank. That means it's just going to send the base request, and the output area is a 200. This is a great test to make sure that your website is alive. That's excellent, but not particularly useful beyond that. So let's take an actual look at a real rule. So this is a sec rules rule that's in the OWASP core rule set called labeled 920170. You can look it up now. And it's actually a pretty easy rule. The idea is first that it looks for a request method, and it checks if it's a GET request or a HEAD request. And if it is, and it sees a content length, it's going to block it. Why would you want to do that? Well, GET requests shouldn't have a post body, and HEAD requests certainly shouldn't have a post body. Those are against RFC specifications. So you might say, how do I test this? Well, this is simple. I just make an HTTP request. But if you started trying to do that with something like curl or Python requests, you'd be blocked because this is non-RFC compliant functionality. So what we've done instead is we've made that test, and it's slightly off the screen, but not too much. We've made this test right here. So you can see in the input section, it's a little bit longer. We specify a method with head. We specify some headers, one of which is content type, and then we specify some data. So the first thing to note is this can violate RFC as much as it wants, which is pretty convenient for us. The next thing to note is that some of this is automatically magically handled, which we'll talk about in a second. So there is actually no content length here. You can overwrite that functionality by turning magic off. It's one of the features. And it also takes care of a lot of other things for you. So it has the capability to do multi-stage requests if you need to log in first and then do something in order to test your web application firewall. Also, it should be noted that things like host are overwritable at the test level, at the entire suite level, I should say. So you can change all of these tests instantly to change a different host, which is going to be pretty interesting for us. So that's a basic test, and they can get a little bit more complicated than that. You can send raw requests if you want. You can encode the request as base64 and send it that way. We use it to sometimes test for SMTP traffic, and if you think that's a crazy, ridiculous thing, we actually see all the time SMTP traffic targeting port 80. It sounds like a strange thing to see, but it's the internet, and anything can happen there. So as we kind of go forward, we'll transition to how we use it for the OWASP core rule set project, which is going to be a little bit different from how Christian will talk about it. So for OWASP core rule set, we use it for regression testing, almost exclusively. We have an entire corpus that tests almost all of our rules right now. And as of core rule set version 3, whenever you commit a new rule, you actually need to provide an FTW test with it. This is completely useful because it means that when someone's going back to look at the rule and figure out if there's something wrong with it, they can look at the test that you thought you were fixing and you should have been fixing, the issue you were addressing. The other thing that we do is we use Travis CI. So many of you might be familiar with this. If you use a different CI stack, this could be something else like Drone. However, in this particular case, it's very popular with open source tools because it's free. And what this allows us to do is build up our environment. So Mod Security and Core Rule Set maintain Docker images that are automatically loaded here. They also maintain Ansible images and Vagrant files and whatnot. But here we use a Docker image that's loaded up. Then we pip install FTW. And the actual test cases are automatically part of the core rule set. So all you have to do is just run them, which is kind of nice. Now, the real thing to consider here is when we run them, we actually end up with a situation like this. And many of you are familiar with this, but if you've never used Git before or Git with Travis CI integration, this is going to be essentially a stop-go message. We're going to say your pull request is able to be merged or not based on the results of that. So we're going to take a quick look at what that looks like for core rule set. And hopefully the demo gods are smiling favorably upon us. So right here, this is actually, if you click the details button, this is what you'd see. We're brought into Travis CI. This one's green, which is a pretty good indication already that something's going well. But if we were to scroll down, we'd see that there's actually a lot of tests. Some of these are testing for very casual things like, is there white space after the rule? I know some of you are like very pedantic about that. As developers, we're pretty pedantic as well. Additionally, we have lots and lots of tests passing here for each of these. So we can see that these are the tests that are actually testing the individual rules. So every time a user makes a commit, we have more and more tests that are added, and we also are testing all the existing attacks against the web application firewall to make sure they're blocked. So normally you'd say something like, oh, wow, storing attacks is a bad idea, but we're actually storing attacks to make sure that they don't work. So there's really no threat here. So we're going to move back to the PowerPoint presentation. Let me make sure I get this correct. There we go. And with that, I think I'm going to transition off to Christian, who's going to talk about a little bit about how Fastly uses FTW in order to test its web application firewall.
Hi, thanks, Sam. All right, so for those of you, for some of you, you might know, Fastly, we're primarily known for building and operating content delivery network. The platform engineering teams are looking kind of expanding it, and one of those things that we were looking at, or that we looked at, that we built, is web application firewall functionality. It's a little bit different for us because of just the way that the CDN is structured. It was really important that the functionality actually occur at the edge. So we didn't want to, create another bump in a wire and have like a cluster of mod security boxes sitting out somewhere else. So there's a requirement where we basically needed to make sure that it was highly integrated, that the WAF was actually highly integrated with our platform. So the other really important thing was making sure that we had solid rules. So we source our rules from three main areas. We have a vendor that will maintain commercially rule set for us. We use the OWASP core rule set, which is what I'm going to be focusing on primarily. And then we also have an internal set of rules that are kind of specific to the content delivery network or things that really bad things that are happening where we need to rapidly establish a rule for it. So all these rules, we're using the sec rule format for mod security. So in order to, but we can't just take the mod security rules and load it into our platform. What we needed to do was write a tool chain which translates the mod security rule set into something that's consumable by our platform. So in this case, it's VCL. So the other thing that was very worrying was we're talking about replicating a lot of code that exists within the mod security code base. And it's not just actually, it's mainly replicating behavior. So we need to make sure that we were parsing out requests the same way that mod security and Apache would be parsing out requests. We needed to make sure that for the transform operations, that we were transforming the data in such a way that it would be identical. So any kind of mistakes in this code would result in WAF-related evasion vulnerabilities, and we really wanted to avoid that. So to do that, we created a test harness, and our harness is slightly different than what Zach describes. It's basically a wrapper that pulls the FTW code in and uses it. But it also does a bunch of other things that we needed it to do. So test scope specification was mainly for making sure, like we basically needed a way to configure which rules that we wanted to test. In some cases, we might not use a certain CRS rule for various reasons. The other one is that in some cases, we actually expected certain tests to fail. So this could happen for a couple different reasons. If we update a rule and there's still like an old test that was kicking around, it might fail for that reason. In some cases, because of how the edge caching engines work, there might be just certain payloads that won't even make it to the WAF code, in which case it would manifest itself as a failed test. So we needed a little bit more granular configuration. What we ended up doing is to kind of get that initial baseline of what we expect to work and not. We basically used Apache and mod security, and then basically ran through our test corpus to kind of to gain a baseline. So the two main objectives for the two main objectives was basically to make sure that our WAF was functioning, but then also make sure, the other thing that we noticed is that certain payloads would trigger many rules. And we wanted to make sure that the payload, or that the rule that was firing was actually based on what the payload was designed to trip. So a good example is you might have a certain payload that gets identified by the WAF, but it might be getting identified by the wrong rules and dropping it. So we wanted to make sure that the rules were functioning correctly. In order to do that, we needed to basically, we created a custom header that we sent with that we inject into the FTW request. And when the WAF receives it, it will basically log that data. And as a part of that data, we actually store the rule, timestamp, and a test ID. And then basically what happens is that when we're running the tests, there's a journal that we store as we're running, and we correlate the data from the journal and the WAF logs to verify, to make sure that every single rule is working properly. So typically when there's a rule change, much like this system that was described by Chaim, we'll branch the rules, we'll update the rule, we'll typically create a pull request, and all our jobs will run on basically on push and on pull, and it will basically provision an environment. It will set up an origin server with a special property that we don't want. We want to instruct Varnish to not cache the data because it was interfering with our tests before. Checks out our tool chain, processes the rules, loads it, and then we're ready to go. The other thing that we do is we're very sensitive about CPU use. So we actually, when we're extracting the rules, we actually run them through a redos checker to make sure that the rule itself is not vulnerable to, the regular expression is not vulnerable to redos. So I'll just skip that. So we've identified a number of issues. Just because I just want to be conscious of the time. We identified a number of issues that we've reported upstream. The issues that we find are basically a combination between the engineering teams and the FTW testing and some of the engineering work that we were doing. Specifically, Federico and Eric at Fastly, they've done a lot of awesome work there. So, and I'm just going to transition, go into. Okay, so this one, this was a protocol enforcement rule where basically the chaining, so it's a chained rule where we had to transform to reduce something to lowercase. So in this case, it's a request base name, and it's looking for specifically a restricted extension. But here the transform was actually happening in the first chain when it needed to be happening in the second chain. So basically what happened is you were able to bypass with using an uppercase.exe instead of, like a lowercase.exe. This one, so with this one, this was a real file include evasion that was found. So there's two problems with this one. This one, basically, there is the URL schemas were incomplete, so it was missing file. And then this was also a case, it was a case insensitive regular expression. So with this, you're able to bypass the rule by using like an uppercase HTTP or instead of a lowercase HTTP. So there's two changes we submitted here. That was basically to make it case insensitive, and we also added the additional file schema. This one was kind of interesting. So this rule basically was testing for session fixation, and so it does three things. It basically first checks to see if there is a common session identifier name, so PHP sesh or whatever framework. And so if one's in place, then it basically will check the refer and it'll check the host. And if with the way that the rule was structured, if it was the operator was using the begins with. So if there is a different refer than there is in the host, then it could be an indicator that basically it's an offsite or off-domain refer, which could be a sign that there's a session hijack in place. And but in this case, we were using begins with, so you were able to bypass it, or the attacker was able to bypass it by basically setting up a subdomain with the target's site. So the fix for that was just to use ends with. So the other things that we find was within our tool chain. So as we were kind of worried when we were doing all this engineering work, we wanted to make sure that everything was working properly. So there's things like incorrect sorting and reordering of transform operations. There's areas where we might have been applying transforms to incorrect rules within chained rules, reordering rules in such a way that the execution of our code would differ from the execution of like mod security, and then just like lexical parsing errors. And with that, I will pass to Chaim.
Yeah, thank you, Christian. So one of the nice things about Christian's work and the work that we received from him back to the open source community is, as part of these fixes, they would also include the FTW test, which means that as soon as they committed the fix, we were able to continuously test that every time we had a new commit, which is pretty much how it's supposed to work. But it's nice to hear about an open source project actually working that way, I suppose. So the future steps, the future research that we have going forward, we have this nice corpus of web attacks now that we can use to very nicely and modularly test multiple web application firewalls. So we've already kind of started on this work a little bit with a few WAFs, but we're always looking for more help, and this is one of the things we're looking to include, or increase, I should say. So we're going to measure the differences between these various different web application firewalls, a little bit outside of the scope for this presentation, but if you're interested, please come see us. Additionally, we have some future research goals and development goals, I should say, that we're looking forward to. Right now, when you write a rule, although they're fairly simple, there's no existing linter, so we're going to add a linter for the rule language using YAML. Additionally, we want to add more positive tests and negative tests. It's pretty helpful to have all these attack rules, but what we also want to do is scrape the top like Alexa 1 million, create a list of negative rules. That way we know what's firing as a false positive that shouldn't be firing. Should be pretty interesting as part of a project, and should generally increase the overall quality of web application firewalls. And additionally, we just want to have a separate kind of task over here for holding vulnerabilities in FTW form for the community to use to test whatever they want, because that's a pretty generically useful form to do so. For instance, if a large struts vulnerability comes out, I know we're picking on struts today, so let's pick on like PHP for no reason. A large PHP deserialization vulnerability comes out that targets another credit bureau, then we could automatically write that rule, and you could use those to test in whatever form. It doesn't have to be a web application firewall, which is kind of convenient for you. So with that, a little bit of how you can find more information about this. On coreruleset.org, which is the OWASP core ruleset blog, we have a couple blogs written up on how to write tests and announcing this feature. You can expect a blog from Fastly and Christian coming soon. Christian will also be giving more detail about his side of the presentation and how he kind of manages VCL and that whole transition at B-Sides Winnipeg. And of course, we have the FTW repo, which is currently, the current version is hosted on CRS-support. That's a fork of the Fastly version as well, so you can find it at either place. And that's available right now, and you can go look at that code. It's functional. You can also just pip install FTW, which is kind of amazing that we got that. Thank you very much, everybody. We'll be up here to answer any additional questions.